gentlemen. I think that there are only gentlemen, so unfortunately, I don't see any lady. So welcome to our session number 8A. My name is, as you can see, Wlodek Kulesza, and I am chairman of this meeting. I am senior professor at Institute of Mathematics and Nature Sciences at Blekinge Institute of Technology in Sweden, in Karlskrona in Sweden. So it is at Baltic Sea, so east coast of Sweden. We have two coasts, west and almost like American. So this is advantage. And we have 1.5 hours for our session. It means 90 minutes. And hopefully all 6 papers will be presented. Each paper has 15 minutes for presentation and for discussion. I hope that the papers are very close in topic, so you will have cross questions, because it will be always more interesting to hear the questions from audience as well. So please listen the presenters carefully and try to challenge them with your questions, so get some more information about it. So this is my duty and my field of interest. I am senior professor, and most of my PhD students that I supervise, they make their PhD in system engineering. So, but my background is in automation and measurement, but now I deal quite a lot with artificial intelligence and especially with Internet of Things, because this is quite closely related to the measurement, what was my background. Okay, so we have the first paper, which title is a CNN-based novel approach to classification of Sacral Hiatus with GAN-powered Tabular Dataset. And there are 4 authors of this paper, but we have a pleasure to listen today Mr. Ferhat Kılıç, who will present the paper. Okay, Ferhat, please start your microphone, and the other microphones, please switch off, that there will not be any disturbances. And please, Ferhat, share with us your screen with your presentation. You have 15 minutes. Please control your time. And if you will have too much time, 3 minutes before the time, I will send you chat with some information that you have to conclude. Is it clear to everyone? Okay. Ferhat, I don't say floor is yours, but the screen is yours, maybe this way.
My name is Kılıç. I'm a PhD student at Yozgat Bozok University. I present today the topic of a CNN-based novel approach for classification of Sacral Hiatus with GAN-powered Tabular Dataset. Motivation about this study is caudal epidural block is usually the most well-known surgical anesthesia technique to deal with chronic back pain. Due to variations in shape and size of the sacral hiatus, the classification of sacral hiatus is a crucial and challenging task during the execution of the anesthesia. It is required in trauma, where surgeons must make fast and correct selections. In the past studies, have just focused on statistical data analysis and methods to increase the success of the caudal epidural block technique on the basis of geographical areas. Today's studies, minimal invasive surgeries using ultrasonography or fluoroscopy can improve the surgical anesthesia. they are related to lower risk of infection, less exsanguination, and complete decrease in disaster. However, they increase the workload of a surgeon, and also they may be less preferred due to radiation exposure, time limitation, and lack of trained and informed personnel. So the aim is to classify sacral hiatus automatically and accurately via deep learning methods not studied so far. Organizing the SI shapes, we focused on the organizing the SI shapes for the feature extraction. So 1, 4, and 6 picture here. Because of their similarity, they are represented by 1 and type M class. 3 numbers in figure 3 by 2 S type V, and in the figure 3 numbers of figure S type U. Type U, SI shape in 5 number of figures is ignored because of their rarity in the population. So we have 3 class, M, V, and U, and their number 1, 4, 6 as type M, and 3 type V, and 2 type U. Flow chart of the sacral hiatus classification. First of all, we manual feature extraction. We make it manual feature extraction 3D computed tomography sequence of sacral bones. The second stage is organizing features as tabular data. Third stage is scientific tabular feature augmentation using generative adversarial networks. Fourth stage, embedding tabular features in 3D images and feeding these images into trained CNN classification, pre-trained CNN classification models. Manual feature extraction. For this manual feature extraction, we used Radiant Deconweaver software. Determined landmarks. We determined a landmarks so to measure the distances between them.
Mówisz do mnie?
9 distance values features are measured between the location of each patient's landmarks, and they are stored as comma-separated values CSV files. You can see here each patient's 9 features and 1 class label. You can see here. Patient 1, this is first sample, and the sacral bones features, 9 features. They are distance values about determined landmarks between measured. You can see here 9 distance values. Here you can see. The original sacral hiatus tabular dataset, name it OSHD, belonging to the first 5 patients. You can see here. It has 123 samples, row or instance, 9 features, columns, and first class label. The original dataset is 123 sample, but this is not enough to train a CNN because data hungry CNN. When this data is not much, sample. So we used generative adversarial network to generate more synthetically about the dataset, and due to insufficient original SHD for training a data-hungry CNN, we augmented it with respect to its feature distributions and their classes. Therefore, we synthetically increased original SHD 874 samples of new dataset. Name it GAN-powered Tabular Dataset, GSHD. They are difference from, you can see this page, heat map about original Sacral Hiatus dataset and generated Sacral Hiatus dataset, tabular dataset, of course. Figure shows the heat map of correlation of original CHD and generated SHD on how strong to each feature relates to each other. White represents strong relations, whereas red represents weak relations. Of course, this is only only this data set is heat map you can see, and we generated heat map. You can correlation between them consists. When we look at these two heat map, we can see they are consistent about they are consistent between them because you can see the colors in two data sets between, and for example 6 feature and 7 feature here, and GSHD'de de aynı şeyi görebiliyorsunuz burada. The class distribution of generated SHD type M 291 sample. In total, training data set 699 data set includes. Test data set 175. Of course, this is after splitting 80% split. 874 in total data sets GSHD. When we split it 18%, trained data set 699 and test data set 175. So we must of course we train the CNN, the tabular data, but we developed a new algorithm to embed generated SHD samples in 3D images using the SuperTML method and named it embedded GSHD. So the tabular dataset is converted or projected to new images. Each sample and their features projected to new images with order and their class labels, type M, type B, and type U. We not used the SuperTML method same, but we developed using SuperTML, a new algorithm. So the embedded generated SHD, they include, of course, images, total images, train, validation, test total. You can see in the table, 874 total in total image, test dataset 175, and validation dataset is 174, train 525 total image. The embedded GSHD, including 699 images, was split into the validation dataset using the rates of 25% with the Keras image data generator pipeline. After the process, 525 train sets and 174 validation sets were obtained, almost the same numbers as 174 in the blind test set. You can see 174 and 175 data set is same, almost the same for robust training. Fifth stage, feeding these images into pre-trained CNN classification models. Keras augmentation techniques are also applied to increase the generalizability of the models and prevent them from overfitting. Thus, deep model consistently saw slightly modified version of new input data and were able to learn more robust features. You can see the rotation of the images here. Each patient's features includes one image. Overall architecture of the multitask process, MTP approach, we use it in the study. First of all, pelvis CD scans, 3D imaging in radiant deconveyor, we observed, and manual feature extraction on sacrum bones. Taking distance measurements between located landmarks and original dataset obtained is 123 samples only. After that, synthetic tabular feature augmentation generated adversarial networks, and we get Sacral Hiatus dataset with generated. And embedding tabular features into 3D images, feeding them in SHD, embedded Sacral Hiatus dataset into pre-trained CNN models. This is overall architecture of the process approach, MTP approach.
Please come to the conclusions. Your time is over, so please conclude your presentation.
CNN models in this study, CNN models employed in the study is Inception V3, Inception ResNet V2, ResNet 50 V2, ResNet 152 V2, DenseNet 124 1, and DenseNet 169 were trained with Keras in third approach. Unfroze all convolutional layer learning rate is, you can see decay rate is proportional to learning rate. Results are let's understand the results. Evaluated performance on MTP on Inception Work 3. The result is train and validation accuracy and loss graphics you can see. This is the correlation confusion matrix, of course. Test data sets, you can remember maybe, of course, 124 sample. Just here you can see 14. 40. Just 40. 9, 1, 3, and 1 mislabeled in this train. And ResNet with V2, we can see here accuracy and loss performance graphics.
Ferhat, I'm afraid that I have to stop your presentation now because you take over time. So just last slide, please. My question, because maybe we can come to the final question. Did your system meet the requirements from medical staff, or in general, can you conclude if the system is satisfactory for implementation directly, or it requires still some improvement?
A conclusion I can talk about, or conclusion I can read. Just time is up. Sorry, time is not enough.
So did your system meet the medical staff expectation, or because I guess you had some cooperation with some medical staff, did you?
Yes.
Do they think that this solution is better than any known solution, or is not?
They are. It is about to. This difference is using generative adversarial network insufficient or limited datasets, tabular datasets, and using CNN. Insufficient or limited datasets. We can use any image, tomography image, 3D. We can observe it, and we can.
Of course, the 3D image is much more informative because you have more accurate or different. So I think that is self-evident that 3D should be much better. But do you have access to 3D images in this kind of imaging in the, I don't know, MR, or because I guess that this image that you presented is from MR, yes?
Computed tomography, CT.
From CT, so 2D, not from magnetic resonance, no.
We used radiant to observe them, show them.
For me, frankly speaking, I think that these images look more like from magnetic resonance because it shows some, the computer tomography is much more flatter, but I can be wrong. I am not expert in this. One question from audience for Ferhat, please. Just one. We are 5 minutes over, so I don't like to punish anybody with shorter time. Okay, if no questions, so I think that we thank you, Ferhat Kılıç, for his interesting presentation. And unfortunately, I cannot say that you can continue discussion in couloirs at coffee break, because unfortunately, we will not meet in coffee room after the session. So this is a little bit more complicated. So thank you, Ferhat, and good luck with your PhD and with your research. Thank you. Thank you.
Thank you for listening.
Please stop sharing your screen. And we are asking now the presenter from Slovakia. And this is Stanislav Ondas.
Yes,
He
yes,
will
thank you.
present his transition-relevance place, machine learning-based detection in dialogue interactions. Stanislav, the screen is yours. You please share with us your screen. Yes.
I'm sharing. Do you see?
We don't see it still.
Okay, I
Please
don't
keep timing.
sorry. Now,
Yes.
now.
Okay. So as soon as you will start, I will start my stopwatch.
Okay. Now you can see my presentation.
Yes. Yes.
Okay.
The floor is yours, please.
Okay. Thank you. Thank you. So
discussion.
I am a member of the Laboratory of Speech Technologies at Technical University of Košice in Slovakia, and in our laboratory we focus on speech technology, speech recognition, and spoken dialogue between human and machine, and all aspects of this human-machine spoken dialogue interactions. One of the problems in the human-machine spoken interaction are significant gaps between turns from the computer and from the human, because usually the computer needs to wait till the end of the user utterance and need to identify a short pause after this utterance to be able to know that it can react or it can speak something to the user. This mechanism behind this speaker switching is often called turn taking, and the turn taking is a type of organization in conversation where participants speak at one at a time in alternating turns. And to be able to be a dialogue participant and to know when and what to speak, you need to be able to detect end of turns and also transition-relevance places, which are places or points where it's possible and it's appropriate to take a role of speaker by the listener. And in case of human-human dialogues, this is the very rapid process, but it's very difficult to have such fluent interaction between human and machine in the spoken dialogue scenario. And this is the problem which we try to work on in this paper, and we focus on the detection of transition-relevant places. And here it's important to be able to recognize turn-holding cues and turn-yielding cues, which are signals delivered from the speaker to the listener. And the interlocutor, possibly the machine in the role of the listener, need to be able to recognize these cues and to decide whether and when to take turn. Okay. Of course, here are some approaches, but mainly these approaches are focused on end of turn prediction. But end of turn is not so. Transition relevant places can occur before end of turn inside so-called turn constructional units, which are the basic building blocks from which individual dialogue exchanges are constructed. And inside these transition turn constructional units, there are also interpausal units, and it's difficult to decide whether these pauses, short pauses, are places which are transition relevant places or not. And as I said, most of algorithms try to predict end of turn, which is not enough for fluent interaction. But this is very similar task to transition-relevant place detection. And here we look at the features and approaches which are usually used in this task. So in case of features, mostly prosodic and energy-based features are used, fundamental frequency and power, but also linguistic parameters and multimodal features, because these turn-yielding cues and turn-holding cues are conveyed through several modalities. Yes, there are very important cues altered through gaze direction, head movement, and gestures, and these things. But the question here, which maybe is interesting for this conference, is that we were looking for the very simple approach which can be easily used in case of IoT simple devices with limited power, with limited computational power. For example, maybe you know devices like Amazon Echo or Google Home, which these devices are virtual assistants, and the dominant way of interacting with these devices is the spoken interaction, is dialogue. And to be able to bring the more fluent dialogue, we need to detect end of turns, transition-relevant places, and maybe all these cues. So in end of turn detection or prediction, the currently conditional random field support vector machines and mostly deep neural networks are used to predict these end of turns. Okay, so in our research, we try to prove simple prosodic features as the most general channel for delivering turn-yielding cues, which are very general, and we at the same time we try to uncover the role of prosody in TRP signalization in Slovak language, because there did not exist enough detailed description of prosody role in TRP signalization in Slovak language. And also we wanted to evaluate simple machine learning methods in the task of TRP detection. So to be able to train some classifiers, we created dialogue corpus, which consists 8 TV shows from the session Under the Lamp. Is a discussion, mostly politician sessions. There were only 9 speakers, 1 moderator, and 8 different guests. And this corpus for each TV show has audio recording, video recording, and annotations. We have several annotation layers. We have textual transcriptions. We have manually labeled TRP points into categories used, where the listener used this TRP point to take the role of the speaker, and unused, which are only possible TRP points. The next layer was the layer of overlapping segments, and we also have a layer of prosodic features, which was extracted by Pratt tool. Okay, so here we can see number of these events, TRP points, in our recordings and the overall duration of these recordings. In the first phase, we performed data preprocessing and feature extraction. We split data into interpausal units and into chunks with duration around 1.5 seconds, which this decision was did at the background of research literature, and each chunk was labeled with TRP or no TRP flag or label. And from these chunks, we extracted frames with the duration of 30 milliseconds. And for each frame, the intensity and fundamental frequency of voice were extracted. So we obtained the data vector of 48 intensity values and 48 F0 values. An example of the intensity or intensity F0 of one chunk are on these pictures at the bottom of this page. On the left side, we can see the segment with subsequent TRP point. On the right side, with no subsequent TRP point. After that, we use this data to train different classifiers using classification learner MATLAB tool. The list of these classifiers is in table 3, and the data sets are in table 2. We train distinct. We try to train distinct classifiers for speaker dependent scenario when we use only data from one speaker. We try to train classifier for 2 male speakers, 1 female speakers, and then we combine these speakers together to see how this decision will impact the accuracy of the system, because we assume that this turn-taking behavior could be speaker dependent. Okay, here we have some results from some classifier groups, and we can see that most of them give us accuracy greater than 90%, and we can see that in this data that combining of speakers. So if yes, we can say that if we have more speakers, we can obtain speaker independent system. The accuracy was very good, but usually less than as in case of one speaker, but not for each classifier. So the next research is necessary to observe these tendencies when we will add new speakers into these classifications. So the best classifier is the ensemble classifier, which uses the random forest method. This machine learning method for classification works by generating several decision trees at training time, and for classification task, the output of the random forest is the class selected by most decision trees. This classifier gives us the best results. So conclusions. Our assumption that prosody plays very important role in transition-relevant place detection and prediction was investigated and was confirmed. This role of prosody is very strong also in Slovak language and can be used to predict TRP points. We were able to obtain more than 90% of accuracy, which is fully comparable with similar researches, which was based on more features or more sophisticated classifiers. So this simplification can be used to use these algorithms also on very simple hardware. But we know that in case of our approach, the situation was more simplified, and also on the background of other researches need to be considered that TRP detection is highly subjective, and TRP points can be perceived by particular person very differently in the different way. So this is the risk of this approach, and this is very hard task to deal with this. So I think it's everything. Thank you for your attention.
Okay, thank you very much, Stanislav. And maybe before I will come with my questions, maybe anyone from the audience has any question, please. Just raise your reaction, and even you can just switch on your microphone, I can see, and let you talk. Okay, Stanislav, could you tell us what is advantage of your method? What was your research question that you put in very beginning? Because you say that its accuracy is comparable and so on. So, but what was the advantage that you will, let's say, have more opportunity to sell your product than the others? What is
okay? Okay, thank you. I think the biggest advantage is the simplicity, because if you have very limited hardware, you need to have enough fast algorithms, because these dialog exchanges are very quick. The truth taking is very rapid. The system should react on the human immediately, just in few milliseconds. So you don't have enough time to compute the complex models and to very complex and sophisticated methods. So we identified this way to use only a very basic prosodic features and simple classification methods as appropriate for example, we have now a robot. It's a humanoid robot, which has very limited hardware, and we want to use this method on this now robot.
Does it mean that you want to apply the system in real time? So
yes.
So it means that usually in the very beginning you should define a latency or delay that is acceptable and to measure. But I haven't seen any measure of the
yes, we need a lot of further work.
If you say that the simplicity, which is the issue of the timing, you should measure the timing of this.
Yes, it's true. It's missing in this work. We need to do a lot of work to measure these factors on the hardware possibly, but yes, we identified this feature extraction method as very quick and able to run real time. So, but very good note from we need to consider these things and to measure.
That you should think about target of using this.
Yes, it's true.
Usually we are very clever in this computing and so on, but we have to remember about users and future users. Okay.
Okay, thank you.
I think that we have to finish your presentation, and we applaud your presentation. Thank you for interesting topic and interesting presentation. I am calling the authors of the third paper, and the presenter name was Hasan Ulutas. Is he present? Because I don't think that I have seen him or anyone from this set of authors that were present when I call it in very beginning. No one from the paper third is present. So unfortunately, maybe they have longer lunch, so maybe they will come at the last one. So we can assume that it's not cancel the presentation, but maybe postpone it to the last of the session. Now we have the paper from Malaysia, and Amjed Abbas Ahmed is the presenter. And the paper title is Design on Convolutional Neural Network Architecture from Non-Profile Side Channel Attack Detection. Please, Amjed, please switch on your camera and share with us your screen. All rules, 15 minutes including, so please be in time with every presentation, especially in conclusion. 2 minutes before I will show you tea or we'll send something, okay? The floor is yours, please.
Okay, my topic is deep learning-based advanced encryption, standard encryption for side channel attack. Presenter, I will present the paper. My name is Amjed Abbas Ahmed. I'm PhD student in UKM in Malaysia, and also I'm a lecturer in Imam Kadhim College in Iraq. My outline for the paper will be abstract, introduction, proposed methodology, result, conclusion, and bibliography, which about the references that I already used in the paper. Abstract. Before I will go into the abstract, I just want to explain that deep learning is a new option that has just been made available to carry out side channel analysis. Deep learning approach for profile side channel attack have demonstrated research till now. In this attack, the attack control over the profile device and can gather many traces for a range of critical parameters to characterize device leaking before the attack. In this study, we apply deep learning algorithm to non-profile data. An attacker can only retrieve a limited number of side channel traces from a closed device with unknown key value in non-profile mode. We try to perform this research, key estimation, and deep learning measurement can reveal the secret key. And the data set, we will use that ASCAD data set. The important for deep learning, the use of a neural network successful has been published, revealed in several times, and we can replicate a number of prior results using this approach. The efficiency of each transformer-based model also it is was evaluated. Software and hardware implementation of a cryptography algorithm include the risk of information leak when used in a chip or device. Data about execution time, power consumption, electromagnetic radiation, sound, cache content, and so on, all examples of presently accessible for side channel data. One well-known encryption system that the side channel attack was able to break the advanced encryption standard. As Patton told that can be used in such side channel attack, deep learning is worth considering. Deep learning needs the attacker to analyze just a little amount of leaked data, such power traces and power analysis to perform attack. The effectiveness of the side channel attack is thereby enhanced. An overview of data of deep learning based side channel attack function is shown in figure 1, which try to explain that the use of deep learning model that was trained on device with a unknown key, an attacker may potentially break the cryptographic approach implementation by target using unknown key. The advanced encryption standard try to explain this figure is the algorithm of choice for our intent proposed encryption. This is known as a popular option for symmetric encryption. Analyzing the several forms of side channel attack data necessity wide variety of approach. We are modified to investigate this issue because increased energy cost a serious threat to the integrity of cryptography device like a smart card. The proposed methodology, the JAX numerical computing library tackle core performance at the challenge, the heart of deep learning and other significant computing tasks by combining Google Accelerator, linear algebra with a hyper optimization version of NumPy and variety of their high performance feature. JAX deliver a huge performance boost in low-level computational and transformation. The JAX Python mathematics library is used by many successful deep learning organizations, including Google's groundbreaking DeepMind team. This is exciting newcomer already, an amazing ecosystem for tools, including the high-level deep learning library, plugs by Google and hiking for by deep learning. JAX bring functional programming mindset to Python deep learning, letting us improve the complexity and prioritization in cluster. In addition, that we test a variety of learning rate scheduler. We test variety learning rate scheduler proposing methodology, input optimization. Most of these tasks were accomplished in by using the deep learning software project that was a part of this effort, among other things. It required developing many things to get it. We devised or decided to create our learning rate finder. We could generate our lecture upper limit and include them in our own individual timetable. This because both architecture and dataset have role in determining the optimal learning rate. Given the lack of appropriate JAX implementation, we adapt to construct our own. The approach present and implemented in past package serve as overall for approach to learn that rate and raise over the course of openware in growth liner. The maximum usable learn is the selected that greatest value, which lose decrease once the graph been to exploit. It will be naturally shrink, make it easier when we look for the figure about the row of block clues, and when we talk about the electronic and how we can the result of learning rate finder and the standard for moving average. The figure 3, we display the training over the curve. In course of our investigation, we come across our novel phenomenon, which is also discussion, and it's possible to network content to improve term and their guessing entropy, even as the validation lose rise and training lose fail, which is opposite of what would normally be considered sign of overfitting. The categorized cross entropy loss function should not be used in a situation according to our work hypothesis. It does not fully explain in the impact outliner on the final estimate, nor does it correctly indicate it. Important to retrieve the prediction, which is more relevant than the raw size of the log probability. In the conclusion, to carry outside channel attack, we develop our own software system. The result allow us to successfully reproduce such just design in order to improve training process in numeric way, including the timing of the learning rate. We perform our data analysis, which include gradients, visualization, and signal to noise ratio evaluation. We found that the proposed model could not work when attack dataset is unknown, and the research follow rigorous methodology. To a lesser extent that we had hoped we were able to apply many transform-based model to ASCAT version 1 variable key data set. And all this is the references. I don't need to go through it. That's the references that we'll use in this paper. And that's it, done.
Okay, thank you very much, Amjed. I appreciate that you finish in time, so then now we have 5 minutes for questions. So I really encourage the audience for asking questions, because the security is the very important topic in any university. So please ask Amjed questions about his presentation. If there are not questions, if you could tell me in figure number 3, this is the slide next to the, yes, if you can, in this accuracy, when I look on the accuracy.
Yes, accuracy evaluation.
Yep. What is the unit of the accuracy? What is this? This is percent, or what is this?
Okay, that's it is the validation accuracy of the training network, which is can over EPO have 2 primary metric used for the measuring, like CNN training and the previous mentioned in this, like in figure 2 and in figure 1. The validation is shown in figure 2, which was derived from attack. Our data set using it is NE equal 30 EPO has for each estimate. The number of training EPO is shown along with horizontal XI, and then validation accuracy of the training network is shown along because we use correct like sub-byte value. The validation of our training much greater than of the other company or other literature review that we check in the. I cut the literature review part from my presentation because I want to meet the time. So I compare my result with other one. Like I find out that our training was much greater of the other literature review or other study has been done even after epoch, which can be attacked. This is from 0 to 30. That's the attack on the data set they're using. We say like NE equal to 3, and we validate that by the accuracy and number of the traces that we use, because there is a number of traces. Each traces count how many traces I need to attack the key to break the key for advanced encryption standard. That's the way we just calculate that.
Okay. So how can you implement this solution on which type of platforms, or how it will be, let's say, distributed, or how it can be used? Okay.
The way I use it, sir, I already used the same data set they used before. But what we did, we just we apply like a partitional number of partial key that can drive it from the size of sample. The size of sample was like 30,000 traces. And what we try, we use like CN convolutional neural network with side channel attack, like to break the key or to guess the key before the attacker, and just recover the weakness in this area before the attacker can find out. I just want try to explain that the side channel attack, it depending on the physical. The attacker, he don't attack the cipher, or he don't attack the software. He attack the hardware. Like when somebody use a machine for payment, or when somebody he use the computer for write code or something, that the attacker will estimate the key depending on physical parameter, like the power, the time consuming, or other physical other thing, like not software. It will be mostly close to hardware.
Okay, thank you very much. Now we are exactly in 15 minutes dedicated for your presentation. I hope that all of us, we are satisfied, so we can applaud your presentation and wish you all the best with the progress of this interesting approach to the safety. So thank you once again, and we have now the paper in the list with number 5, and it is about artificial bee colony algorithm based very fast renewable energy system optimized tool design. And we have the presenter who already showed up earlier, and is Cemil Altın. And please, share with us, yes, your screen, make it full screen.
Okay, can you hear me?
Yes, we do, really. We can see you even, and we can see your presentation, but it is still, yes, now it is in full screen. So the rules are as for everyone. You have 15 minutes time to finish presentation and discussion. I hope that you will keep the timing. Good luck, and the floor is yours, please.
Thank you. Hello, Chair and dear audiences. I am Cemil Altın from Wlodek University from Turkey, and my topic is artificial bee colony algorithm-based very fast renewable energy system optimization tool design. My content is start with introduction, aim of my study, state of the art, originality of my work, material and methods, ABC optimization algorithm, dispatch strategy, economical calculation, results, and conclusion. The use of environmentally friendly renewable energy sources has become inevitable due to the environmental damage of fossil energy sources and the fact that they are unsustainable due to their finite nature. Solar and wind energies are the leading renewable energy sources, as you know. Renewable energy sources are more efficient when used in hybrid because they complement each other. In other words, continuity of the production is ensured because while the panels don't produce at night, the wind turbine produces. While the wind turbine does not produce in cold, windless weather, the panels produce. In addition, the efficiency of hybrid systems is increased by adding batteries to the hybrid system. When production is higher than consumption, and storing the energy and using the stored energy when consumption is higher than production. Hybrid systems become the most efficient when they are optimized, as I said before. In other words, it is important to use the optimum number of components. Therefore, interest in the optimization of hybrid renewable energy sources has increased considerably in recent years, and much research has been and continues to be done in this subject. The most commonly used software for the optimization of hybrid renewable energy sources is Homer. Homer is a software which makes optimization for the hybrid renewable energy systems. But Homer has two main advantages. One of them, high computational cost and long optimization time. The other one, challenging search space generation process based on trial and error. Aim of the study is to provide solutions to these disadvantages of Homer. How Homer works? Firstly, we add components of renewable energy sources like PV panels, wind turbines, batteries, converters, generators, which we want. we firstly add these components. Then we enter the load profile. What is our load? We all enter the 24-hour of our load profile. After we add some economical data to our components, like the capital cost, replacement cost, operational and maintenance cost, and the important one is that sizes to consider. As I put stars on that area, we add sizes to consider. That means that during the optimization, system Homer uses the values we put here, and also we enter some economical data and sizes to consider all the other equipments, like in PV panel and wind turbine, and batteries and converters. This star put places is very important because these values are comprise our search space. Homer finds the optimum solution from these values. So the difficult side of the Homer is to creating search space. Then we enter meteorological data about wind and solar data. The data is means of the months. Yes, mean of the months. Then we add economical inputs and constraints. We use capacity shortage generally in Homer. So these economical inputs and constraints, after these inputs, we simulate the system and start the optimization. And here we entered 16 size for the PV array, 11 for the wind turbine, and 11 for the batteries, and 11 for the converters. And the search space is comprised from these inputs. If we put more data in search space, the simulation time longer and will be longer and longer. As we add here, the computation time will be longer. What's solution? Solution is that a meta-heuristic approach. Optimization of hybrid renewable energy sources is quite challenging because these models are non-linear and consist of mixed type variables that cannot be solved by conventional optimization methods. So meta-heuristics are efficient because they can easily handle a range of complexities. A class of optimization algorithm known as meta-heuristics aims to tackle challenging optimization problems by mimicking social or natural phenomena. In particular, multi-objective optimization meta-heuristics are best suited for optimal hybrid renewable energy sources. This is because the high-res models incorporate multiple criteria such as cost, performance, and reliability. If we look the state of the art, meta-heuristics algorithms are used before in many papers, as we see here. Because of the time, I cannot tell detailed. But before meta-heuristics are used in harass optimization, and still we are using it. The difference of this work from state of the art is that nearly all the papers using LPSP, loss of power supply probability, for the reliability parameter, and for the first time we are using capacity shortage in the optimization. Because Homer also used capacity shortage, and capacity shortage has several advantages over LPSP. As you can see, this graphic from a study which made this year, and as you see, LPSP is the most used parameter, but there is no paper which capacity shortage is used before. The work is made by Hussein in this year. This is a state of the work study. So as you see, there is no capacity shortage used before. I have a limited time, so I will pass here fastly. Material and methods. This is the outline of my work. As I told before, MATLAB, we here also enter yearly load profile, hourly methodological data, constraints and upper and lower limits of the search space, and determine artificial colony algorithm parameters, cost data of the components, and the optimizations process is, as you see here, ABC determine a component size, and if cost function is minimal, then cost function minimize, and if the reliable and sort the optimum configuration is achieved. If not, the components are resized, and all the process go like that. ABC algorithm is a methodistic algorithm. This is the flow chart of it. It mimics the bees, how bees find food source. It just depend on this phenomena. And this is my dispatch strategy. Dispatch strategy is the energy flow of the components between the components. And this is the economical flow chart, how we calculate the cost function. This is cost function flow chart. I have limited time, so I cannot tell all them. I wish you read from my paper. And the results shows that results are nearly the same ABC and Homer, as you see, in terms of economical results, in terms of electrical results. As you see in table, all the values are close each other, but when we look to simulation time, this is the advantage of my work. Simulation time is 15 minutes in Homer, but in ABC it's only 124 seconds. It's nearly 2 minutes. Nearly 8 times is faster from the Homer. Yes, as we see in discussion section, methodistics algorithms are superior from Homer in terms of computation time. There are lots of papers about that. They told all the meteoristics which used are superior from the computation time from the Homer. Yes, it's going on. And also, as we stated before, there is no study which includes capacity shortage and meta-heuristic algorithms together. We can see from literature review and state-of-the-work papers, some of the state-of-works are Egegia et al. In this year, Ratot and Subramanian in last year, and so on in last years. The results of the findings obtained from these studies, it is the first time that the capacity shortage parameter is used in hybrid system optimization with meta-heuristic algorithms, which reveals the originality of this study. I am concluding.
Please try to conclude very fast. You are out of time.
Yes. In this study, it's aimed to design a faster, more convenient, and easier optimization tool than the Homer software. According to the results and supporting studies in the literature, the targeted aim has been achieved. In future studies, a tool that can both generate realistic load, wind speed, and radiation data synthetically, and make optimization with these data can be designed. Thus, a large amount of input-output data required for optimization with deep learning or machine learning can be produced, and these methods can be included in the optimization processes. Thank you very much.
Okay, thank you very much for interesting presentation. Could you please show this slide? Or maybe someone has a questions. Not necessarily me, must always ask question. I know that as a teacher, I am always. Yes, please.
I can.
Stanislav, please.
Yes. Okay. Thank you for a nice presentation. I'm not sure this optimization can be used also in small sources of energy.
Yes.
Or yes,
Yes.
And in this case, if there are some energy from sun and some wind turbine, it's possible to optimize also consumption in the according these energy sources in the house, or to control air condition system, or yes, these things.
Yes, also micro renewable systems can be optimized with this algorithm, because all things depend on this dispatch strategy. If you design this dispatch strategy logically, it will optimize all the systems, no problem.
Okay, so it's very nice. Thank you.
Could you please show the conclusion slide, because I have some, because when you use the term, the conclusion slide, just my comment only, the conclusion.
Yes.
Please.
Okay.
Okay, you said more convenient. So this is very general. You have to be more specified. What does it mean convenient? You know, so you have, because I understand that it's faster, it's more accurate, or easier also. That, what does it mean easier to optimize? Easier, more accurate, and so it's better if you use more quantitatively defined quantities and so on, so it would be easier to judge it. But anyway, I just short comments and so on. So thank you for nice presentation, and good luck with your future use. And this is very useful, of course, approach, because a lot of us suffer of the energy and also of the renewable energy, which is a target of many universities and so on. Thank you very much, Cemil, and thank you. And I see that Serkan is now waiting for his turn, and I hope that he has still energy to present it because he spent a lot of energy on listening. Cemil, please you close your sharing.
Okay, I'm closing.
Oh, yes, thank you. So, Serkan, please share with us your document, your PPT, or whatever is this.
Yes, sure.
And there
I
is-
hope that you see here.
We have, yes, it is visible. So the title of your presentation is Modified Background Propagation Algorithm with Multiplicative Calculus in Neural Networks. So we are here very, let's say, rich with neural networks approaches. Okay, could you please make the camera that we can see more than just top of your head? Oh, much better. When I see your lips and sound, it's much easier to understand when you are talking. Thank you very much. The floor
is it
is yours.
normal, yeah?
Yes, 15 minutes, please start.
Okay, thank you, dear chair and dear my respected colleagues. And I will be very happy to be here, and I really appreciate for the organizers to be here for this electronics conference, and I'll try to catch up the time, and let me directly start it. Okay, my title is the Modified Backpropagation Algorithm with the Multiplicative Calculus in Neural Networks, and I'm Serkan Özbay, and I'm Assistant Professor in Department of Electrical and Electronics Engineering in University of Gaziantep, Turkey. Yes, here is the outline. And in this roadmap, I will first mention about the introduction and the motivation, and then I will just give an overview of backpropagation, and then I will introduce the multiplicative calculus terms, and then I'll talk about the proposed algorithm, and then I'll show the extensive results, and finally I'll make a discussion, and then I'll do the conclusion. Yes, as you know, if you are interested in the neural network concepts, then you know the backpropagation, and it's known that this is the most widely used algorithms for training the feed-forward deep neural networks. Although we have many useful advantages in many successful applications, but we have some drawbacks, such as we need a lot of time for training the network so that the convergence tends to be significantly slow, and the next that the learning process may get stuck at a local minimum. And this study is basically addressing a novel solution to overcome those two problems, which are, again, as I said, the slow convergence rate problem and also avoiding the local minima problem. And this study and this paper will introduce a modified version of backpropagation algorithm with the multiplicative calculus. Okay, let me say what we understand from multiplicative calculus. It's actually the alternative to the classical calculus form, and it's defining new kinds of derivatives and integral forms in multiplicative form rather than the addition and the subtraction forms for the integral and the derivative forms respectively. And to the best of my knowledge, that study could be the first study on the use and the application of the multiplicative calculus on this field. Okay, let me just give a quick overview of backpropagation. And as you know that in feed-forward neural networks, when one of the inputs in the training data set comes to produce the output, the initial information is flowing up to the hidden layers at each layer, and this process is called forward propagation. And in training the networks, the forward propagation lasts until it produced an error, or sometimes we call as a cost. And the backpropagation algorithm simply enables the information from the coast and then propagating in backward direction through the network to compute the gradient. And here is the standard normal backpropagation algorithm framework, and I hope and I know that you are familiar to the standard version of the backpropagation. And now, as I said to you, I tried to apply the multiplicative calculus in the backpropagation algorithm. And let me just briefly describe the multiplicative calculus. And we know that there are two main tools in calculus, you know, the derivative with differentiation operation and the integral with integration operation. And we know that the differentiation and integration are the infinitesimal versions of the subtraction operation and the addition operation on numbers respectively. And we know that the close connection between the derivative and the integral was first observed by Newton and Leibniz independently in the second half of the 17th century. And now, let me introduce the multiplicative calculus. And it's known that the many physical quantities in nature are in the form of the exponentially varying type. And as an alternative to the classical calculus form, the multiplicative calculus was proposed for exponentially varying function. And here is, I have written some valuable references, and they are mentioning about the multiplicative calculus form. Okay, here is the mathematical formulation for the multiplicative derivative and the multiplicative integral of a function. Although I used the multiplicative derivative form, but this is just for understanding the concept. And as you see here, the definition is changing. And as I said, instead of either subtraction or the addition forms, now we have the multiplicative forms. And as you see, there will be some exponential terms here. And at the last section of this page, you see the connection or the relation between the multiplicative derivative form and the classical derivative form. Okay, what I did here, I tried to use the multiplicative derivative form in the backpropagation algorithm. So I made some improvement, and exactly the novelty is here. I used the multiplicative form of the derivative in the computations, and actually I just did it for the last layer, not the hidden layers. I did some experiment about it, but the best solutions were obtained by just performing it on the last layer. And I have selected the sigmoid function as an activation function on both layers. Okay, here is the mathematical representation of the proposed algorithm, and here I have written the sigmoid function formula, and then in applying the multiplicative derivative, and you know that the backpropagation algorithm requires the differentiation of the transfer functions on the layers, and here I have made a derivation how to make this operation, and at the end of the slide you see the multiplicative derivative of the sigmoid function. Okay, here I have written the proposed algorithm framework, and as I said to you, the novelty and the improvement is on the use of the multiplicative derivative at the output layer, but still I use the normal derivative in the hidden layers. Okay, in order to analyze the performance of the proposed algorithm, I have selected some linearly inseparable problems, and I have conducted some experiments with using some shallow neural network models. And in the first case, you see we have a well-known classification problem, which is exclusive OR problem, and you know that this is inseparable problem. And I have selected first the two inputs exclusive OR classification problem, and I have selected such a neural network. And as you see, the network has two input nodes and one output node, and we have one hidden layer with two nodes. And as you see in the classification problem, the training data set size is just 4. Okay, I have selected some initial weights and the bias values for understanding the performance of the algorithm. And in order to make comparison with the standard version, I have selected the learning rate as 0.2 and then the learning rate as 1. And now you have seen those figures, and it is showing that the proposed algorithm is quite fast as you compare with the standard backpropagation algorithm. And as you see, the horizontal axis is showing the number of epochs, and the vertical axis is showing the average of the training error. And in the second case, I have selected another linearly inseparable classification task. And now I have chosen the 3 input nodes, and again, 1 output node and 1 hidden layer with the 4 nodes. And I have selected such a classification problem given in this table. And again, when I choose some initial weights and the bias values and choosing the learning rate as 0.1 and then 1, and as you see, there will be a significant correction or improvement on the speed of the algorithm. And in trying to catching up to time, and here we have the third case, and now we have another linearly inseparable classification problem, and I have used the same architecture as in case 2. And if I show the comparison and performance analysis of the standard backpropagation with the proposed algorithm, and then as you see that again, we have reached the outstanding performance comparing with the standard backpropagation. Okay, also there was another problem, like as I said, there was a slow convergence problem, and also the algorithm may get stuck at some local minimum point. And now I also analyzed the algorithm for understanding its behavior about the avoiding the local minimas. And here is the results for the both 2 input exclusive OR classification problem and then the 3 input linearly inseparable classification problem in case 2. And as you see that we reached that the algorithm is converging to the not the local one, it's about the global minimum point. Okay, actually, I did exactly the performance tests for some specific initial values, and that's why in order to make more generalized performance evaluation, I have chosen the different initial weights and the biases randomly, and then I tried to see its performance. So here I conducted 100 different random initial weights and the biases, and I generated the numbers in the interval of 0 and 1. And the next slide shows the comparison of the proposed algorithm with the standard backpropagation algorithm for various learning rates. And the similar analysis is performed for testing the algorithm on avoiding the local minima problem again. And exactly, I have chosen the success rate that it's reaching the global one, but if it's going to and converging to the local one, and then I said this is failure, and here is the result and comparison of the proposed one with the standard version, and I have obtained 96% success rate, but the standard one is just 85%. And finally, in order to make the comparative analysis of the proposed algorithm with the other improved versions of the backpropagation algorithm, I have chosen two benchmark problems, and I have modified my algorithm with the problems that I have seen in the literature, and I first choose the two-input exclusive OR problem again, and I have chosen 2-to-1 network, and here is the results of the algorithm with the other modified versions of the backpropagation. And in the second case, I have selected another modified exclusive OR problem, and the last sketch and this table shows the performance of my algorithm with the others. Okay, as a conclusion, in the study, I have introduced the use of the multiplicative derivative in the use of the backpropagation on the neural networks, and there was two main issues about slow convergence rate problem and avoiding the local minimas. And as I conducted the several experiments, then I have seen that about like 80% reduction in error as compared with the standard backpropagation, and also 96% success rate has been achieved in avoiding the local minima problem. And thank you for your patience, and thank you for listening. I hope I catch the time.
Yeah, perfect time, but still 1 or 2 minutes for questions. So if anyone from audience has any question, please.
Yes, please, sir.
Yes, please, Amjed, please.
Okay, sir, I just have, first of all, thank you very much for clear presentation and very nice, good work. My question is, I just want to ask about the data set that the author he used. I don't catch the data set he used it for this.
Yeah, actually, I discussed about the data sets. It was very small, as I said, like I have chosen the exclusive OR classification problem, and it's just 2-input form. And as you know, just we have only 4 different cases. And in the case 2, again, I have just 4. And in case 3, I have selected totally 8 training pairs, as I said, yeah.
Okay, thank you. Thank you very much.
You're welcome, you're welcome.
So it means that more or less you show some evaluation of the algorithm, but you didn't show verification. So maybe you need to use the real data and to compare it with the, let's say, other algorithms, because we can see from this evaluation of simple cases, but probably it is needed now to make real validation of the method and so on.
Yeah, sure. You are correct. And I just took some empirical results, and my future study is about the use of that modification on the real problems exactly. So I'll try to do, and I'll try to apply it in for the different classification multitask problems. Yeah.
Okay.
Thank you.
So very interesting approach, and I hope that it will be possible to implement it on some tools with the neural networks and so on. So this will be useful for, because this problem is very general and very complicated to get, especially this local, the optima and so on. So it's a problem with convergence and so on. Any more questions? If no more questions, myself, I thank you all presenters, because I think that mercifully one group quitted. So we have just 10 minutes over time, elsewhere it will be much worse. And I hope that the Professor Darius is happy with the timing. And so Thank you very much, and thank you for opportunity to chair this meeting. Thank you, Darius, and thank you, my friends, the presenters. Maybe next year we can see each other in Palanga, I hope, because I really think that the online presentation is not as exciting as the real life presentation. So I hope that we see each other and chat next year in Palanga. Thank you, Darius. Thank you, everyone. Thank you.
Okay, thank you, Mr. Chairman.
Thank you, Mr. Chairman.
Participants, their presentations.
Thank you.
Okay,
Thank you.
see you.
See you.
Take care.
Thank you, sir. See
Good
you.
luck with your research.
Thank
Good
you, sir.
luck. Goodbye.
Bye-bye. Bye-bye.